What the fuck is up, pussies? My name is Pussy, and you're also a pussy. It's the 15th of November, 2021. This is a Flint Nation podcast. Let's go! 8:12. Alright. So, let's talk for like 15 minutes before I... yo. What was I saying? La 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 la. What was I saying? Anyways, let's go to training. It's Monday, so... Hey, that's 5 years. Why does they have one beer and watcher? One beer and watcher. Okay. Dope. Nike Air Jordan 1 Mid GS University Go basketball shoe size US 4Y. Alright. 5 views. No bidders and watches. Oh man. A lot of people paying through Ping. Happy trading. Okay. Um, 8:15 is created to do today list. So, my sister's home, and, my sister, she has a very low EQ. She's a high IQ, probably. If she did an IQ test, she'd probably get a high score. But the reason that even subconsciously I'm speaking quieter than I normally would, and I don't want to be, I want to be speaking loud, like not giving a fuck, you know. But it's because my sister, she's strange. She's strange. The other day, I don't know if you remember, but like halfway through, I was like, am I getting yelled at right now? That's what my sister does. She would have heard me talking and then screamed at me. She doesn't have an, like, she's got the EQ of a 5-year-old, you know? She's probably got like, I don't know, maybe 110 IQ. Not that I don't know much about IQ, but above average IQ. But yeah, she's just got the EQ of a 5-year-old and just will pop the fuck off like that. She starts screaming. The other day, I was outside her room doing some shooting because there's a white table out there alongside a white wall. So it's perfect to get my ring light and take photos of stuff I'm selling on Trade Me. I was there. She was just going, shh, but very violently, like, shh, like that. Because she just gets angry and just doesn't know how to control her emotions at all. And she's probably still like that to this day. Right, future son? She probably still is. But there's been times where she just lost her fucking shit, man. Like, there's been times where she's like 21 years old now. 20 years old, I think. Yeah, 20. She's 20 years old. So she's an adult. There's times where she's come home, like being 20 years old at university. She's come home and just like lost her shit over something I said. Usually it's me. Over something I said, and like started just crying in front of me, in front of everyone, and started punching her head. Like crying and punching her head. She's done this twice now. She just starts crying and punching her head. Because if she's like losing an argument or anything just isn't going away, she just fucking loses her shit. Like really loses her shit. If she's losing an argument or something like really isn't going her way, like she thought it would, fuck man, she just goes off the fucking rails. And it's mainly because it'll be a combination of genetics, like she has a low EQ because of genetics, but also the way my parents handle it is not fucking good at all. It's like on those TV shows where you see like the kid is a total fucking menace, you know, like playing Fortnite all day, fucking swearing at there. Like, I remember this one episode of Dr. Phil where there was this kid that, like, Fortnite kid that would swear at the TV and shit, and then, like, call his mum a whore and, like, tell him to get food and shit. And she would get food, and then she'd complain about her son. She'd get food for her son and, like, bow down to it, and then complain about her son. But it's like, that's kind of like what my parents do to a lesser degree. They kind of avoid Katie. Like, this morning, my old man came to me and he said, "Oh, Flynn, can you do me a personal favour and just not talk to yourself, not do this podcast, because I just don't want to upset the beast, don't want to upset Katie." Like, no, that isn't how you fucking deal with someone like that. That isn't how you deal with a 20-year-old who still thinks the fucking world revolves around her and she's got an EQ of a fucking 3-year-old, so we'll pop the fuck off if anything doesn't go away. That isn't how you deal with it. Like, bowing down to what they want, that's not how you deal with it. If your fucking son is playing Fortnite all day, swearing at the TV, and calls you a whore and tells you to get a sandwich, you don't get this fucking sandwich. Hoping that, okay, if I get the sandwich, he won't call me a whore. Hoping that, oh, if I don't speak loudly, Katie won't lose her fucking shit. Like, she'll lose her shit no matter what. Over the slightest shit. When she started crying and punching her face at one time, it was because, if I'm remembering right, she was like, she had to get a bus or something down, and I was like, I said something like even then, I'm also kind of doing that to a degree, what my parents do. Like, what I want to be doing is the opposite, where I actually try and fucking piss her the fuck off. Because fuck her. Like, the world doesn't revolve around you, buddy. And I just find myself having such, like, negative vibes. Like, the whole fucking family just becomes worse fucking people when my sister's around, man. Like, I've just got such negative vibes right now. I don't like it. I don't like the negative vibes. But I mean, it's up to you to not have those negative vibes, man. You can't pull a Katie and just blame everyone else for what's going on around you. You've got negative vibes, that's your problem, Flood. And that's a fact. And that's a fact. I find myself becoming a lot less articulate around it. Like, I can't actually, like, Like the other day, she outside the door, she was like, shh, and she came out, she was like, what are you doing out here? I'm just not articulate with her, man. Everything is an argument for her, and I'm somehow losing to her. Yeah? Because you participate in the argument, and you shouldn't participate in the argument. But she turns everything into an argument. It's about not giving a fuck, though. Gotta continue to not give a fuck. But I'm giving a fuck right now, and it's fucking annoying. Anyways, let's write up this to do today, and then do some studying. Yeah, that looks like a pretty good idea. 8. Okay, after this, it's kind of now. 8:30 to 10:30 study, 10:30 to 11 eat, 11 to 12 create 4 tickies. Most likely, there's a good chance that you'll be able to see me interact with Kate when she's. I think you saw me interact with Kate before when she wasn't being a fucking psycho, but she's got her roots. She digs her roots down, and yeah. Now she'll probably come in. She'll probably you'll probably hear her. She'll probably do some dumb shit like scream at me because I'm talking. Probably wake her up, and hopefully she comes into the room so you can see her me interact with her, and hopefully I keep my cool and I don't give a fuck. I don't give a fuck, nigga. 8:30 to 10:30 study 4 cycles. 10:30 to 11 eat, 11 to 12 create 4 tickies. 12. To 11:40 create 4 tickies. 11:40 to 12:30 study CJ drop shipping. 12:30 to 1 lunch. 1 o'clock to 3 o'clock. I'll probably do more study, yeah. Study 4 cycles, 2 cycles on YouTube videos, physics, both remaining weakness, 2 cycles on YouTube. Past exams on YouTube. No, 2 cycles on NCEA per past exams. Past exams. Right, 3 to 3:48. She 3:40 to 4. Book all couriers. Bro, I was so pissed off because I went on Facebook. I went on Facebook to see the garage sales. Yo, that kid's lost a lot of weight. What the fuck? Towards a refrigeration. What the fuck's a refrigeration? In year 13 mechanical engineering. Why the fuck didn't I do that? It's too much of a fucking nerd at high school. Jesus Christ. I was too scared to do woodworking. I did woodworking one year. But I should have done what's the other one? Metalwork. Load, you fuck. You got you in mind. I was so pissed off at this garage sale because it was such a good one on Sunday that I missed in Palmy because they posted the listing fucking as it started. What dumbasses. So it's just like word of mouth. I'm not hearing no word of mouth around garage sales. Such a good one, and they had a PS2 they were selling, I can see, and some games. I would have bought that shit, man. Fuck's sakes. So I went to Fielding. Did buy some Nike Air Jordan style. I think they were so pretty good. I got you in my mind. You in my mind. Famine Technique. Open a new tab. 2014 exams. Okay. Six to 6:30. Read. 7 o'clock. Stretching. We have to stretch so much for legs. Jesus Christ. I really do, because my knees fucking get hurt so easy. Notice you say that with my chest. I'm able to go like. Fuck, am I just flexing the left one? I'm able to flex them. There's a lot of arm movement in there. Isn't that cool? Isn't that cool, Future Flynn? And I have to be willing to this chucking a note section. Be prepared to rearrange schedule based on Kawasaki motorcycle fix. Fair point. Alright. Why have I got two things? Okay, let's go. 8:30 on the dot. Let's go. Let's get it. Let's put out a timer. Let's be generous and start the timer now. Then let's make our way over to Learn Coach. Learn Coach. My last chemistry one, I think. Oh, maybe I'm not. Maybe I am. I think I am. Cause I got you in mind. You in mind. Exam date? 7th of December. This website is so good. Equilibrium principles. Let's go. Yep, let's go. Equilibrium principles. Little kids going to school. Think that they're so cool. Maybe I'll watch this basic solubility equilibrium video. This is probably the one that I'm best at, look here.
Hey there everyone, and welcome to Chemistry 3.6 on solubility, equilibria, and aqueous solution. in this topic. We'll be giving a general introduction to the topic
I'll do
and doing a wee bit of revision.
precipitation.
Hey there guys, and welcome back to Chemistry 3.6 on aqueous solution and solubility.
Okay.
In today's PowerPoint, we're going to be talking about predicting precipitation, which involves using a series of equations to work out whether a solid will be present in a solution. A new concept that we're going to be looking at today is from level 2, and it's the equation N equals CV. And this equation relates the number of moles of an ion in a solution to the concentration of the ion in the solution and the volume of the ion in the solution. We're going to be needing this equation today, particularly to work out concentrations.
Hey, yo, you are
So
pussy.
just rearrange
You
this
are
equation to
pussy-ass
give us
bitch.
concentration, and you'll see that it equals C equals N over V. I like to think of it as cats knocked over vases, but each to their own.
Just
First thing
simple
we're going to be
as
looking
it
at in
is, man. Don't
predicting
fucking overcomplicate
precipitation
this shit, man.
is working out what equation we use to predict it. And we use something called the ionic product, and you write that as IP. The ionic product is calculated in the exact same way as Ks, so it's again products over reactants. But the difference is Ks tells you how many of a pair of ions need to be present to cause a solution to be saturated. The ionic product is the exact same thing, except it can be written for any solution, regardless of whether that solution is unsaturated, saturated, or supersaturated. Now I'll explain that concept a bit further now. So you can see for a solution of lead hydroxide, Ks equals Pb2 plus times the concentration of OH minus squared. And you'll notice that IP is calculated in the exact same way. And because it's calculated in the exact same way, you might be thinking there must be a point where IP and Ks are equal to each other. And there is. When IP equals Ks, the solution is saturated. The best way to think of this is IP is the amount of two ions we're adding. That amount can be any amount. You could be adding 1 molecule of those ions, or you could be adding 1,000 molecules of those ions. Ks, on the other hand, is the concentration of that pair of ions that's required in order for the solution to be saturated. And so there are three main scenarios to learn. You need to learn when IP is less than Ks, you need to learn when IP is equal
Jesus
to
Christ,
Ks,
this
and
guy,
you need to
man.
learn when IP is greater than Ks. If the amount of stuff we've put in is less than the amount needed to saturate a solution, then the solution is going to be unsaturated. And that means if we were to add even more solid, some of that solid would dissolve. When IP, the amount of stuff we're putting in, is equal to the amount of stuff we need to put in to saturate a solution, you're going to say the solution
what
is
the fuck?
saturated.
Move
Saturated is less than the amount needed to saturate the solution, and so the solution is unsaturated. If IP, the amount of stuff we put in the solution, is exactly equal to the amount that we need to saturate the solution, we call the
IP is equal to
solution
KC.
saturated, meaning
Easy.
that there is no
KS,
precipitate,
easy.
however the solution is completely saturated and no more solid will dissolve. If the IP we work out is greater than Ks, or the amount of stuff we need for the solution to be saturated, that means we've completely saturated the solution and there's some solid left over. And the solid that's left over cannot dissolve, so it sits around and forms a precipitate. So let's do an example question to do with that. The Ks for calcium carbonate is 5 times 10 to the negative 9. Will a precipitate form in a solution where the IP for calcium carbonate is 8 times 10 to the negative 11?
What the
So
fuck
this is a
this
nice
example
easy question. We just need to look at the Ks and the IP and work out which one is
IP is
bigger.
more than KS.
A lot of people mess up easy equations like this because they
That
look at
means
the
a precipitate
11
will not
and they look
form.
at the 9 and say IP is bigger. However, this is not the case. You've got to remember that this is a negative 9 and this is a negative 11. So the negative 9 is the bigger number. So from that, we say that Ks is greater than IP. And so the amount of stuff we've added is less than the amount of stuff we need to saturate the solution. And so if we were asked to say what type of solution this would be, it's an unsaturated solution and a precipitate will not form. So let's go to a slightly harder example question now. So in this situation, they're asking, will a precipitate of AgCl form when you add 75 mils of a certain concentration sodium chloride solution to 25 mils of a certain concentration silver nitrate solution? And they've given us the Ks for AgCl. So in these situations, we need to work out IP, and we need to compare IP to Ks, so we can sort it into being unsaturated, saturated, or supersaturated. This may seem like quite a complicated question, but you'll be fine if you just apply the same 3-step rule that we've been applying to all our other solubility questions. So write out the equation first. So the IP for AgCl equals the concentration of Ag plus times the concentration of Cl minus. So what information are we given?
And
We're
just
told the concentration of Ag plus
Ag
is
in
4
3
times
times
10 to the
concentration
negative
in
3,
ACl.
and the concentration of Cl minus is 6 times 10 to
Oops,
the
I
negative
totally
5
meant mix up the
before
concentrations.
mixing. And this before mixing part is very important because you're combining solutions and so the volume is changing. Previously, the volume of the NaCl solution was 75 milliliters, and the volume of the AgNO3 solution was 25 milliliters.
Wait, we've got the concentrations
Now
here.
you
Why are we figuring out moles?
mix them, the total volume is 100 mils. And if you remember this equation, C equals N over V, if volume is changing, it will change the concentrations of Ag plus and it will change the concentration of Cl minus. So this means we need to work out the new after mixing concentration of both Ag plus
Yeah, might be.
and Cl minus before
Just
we can
times
work
that by
out IP.
7.75
So there are
times that
two
by
methods
0.25.
you can use to do this. And I'll walk you through both
Oh
and
my God,
explain,
they're both fucking
because there's
simple,
nowhere else Cl, this is why it's always times the old volume divided by is equal
I
to
remember
the
watching
old
this.
concentration times the old volume divided by S, and they've also given us this time the molar mass of NaCl.
That's pretty basic. Acid base equilibrium, what's that about? I honestly can't remember. Resume the fucking timer.
Hey there guys, and welcome back to Chemistry 3.6 on aqueous solution. Hi there everyone, and welcome back to Chemistry 3.6. Today we're going to be looking at acid-base equations and how they relate to the solubility principles we covered in the first.
What do I need to go over? I know this shit. Common ion effect, complex ions, pH changes in solubility. I think that's even a thing here. Buffer solutions, nah, it'll be up here. Maybe it's in solubility equilibrium. Yeah, fuck it. This is the only video that I need to watch.
Hi there everyone, and welcome back to Chemistry.
Yeah.
Hey there everyone, and
So let's skip
never
forward here.
included in the solubility product expression, giving us a Ks of Pb2 plus times CO3 2 minus. The second step is we write out the info the question gives us. So we know the Ks for PbCO3 is 7.4 times 10 to the negative 14. But how is this going to help us? Because if we put it in the equation now, we have 7.4 times 10 to the negative 14 equals the concentration of Pb2 plus times the concentration of CO3 2 minus.
Look at it
There are
do.
two things we don't know in this
Shit,
equation, which
you're gonna
means
do
we
4x
can't
squared.
solve it. But because we've written out our equation, there is something else that we know. We know that one lot of PbCO3 turns into one lot of Pb2 plus and one lot of CO3 2 minus. Well, let's say this equation was happening in water. We now know that the amount of Pb2 plus and the amount of CO3 2 minus
Dude,
present
take the
will be
microphone the
the
fuck away
exact
from your mouth,
same
buddy.
concentration. Because when a PbCO3 splits up, it has to split into both these things. It can't just produce a Pb2 plus and not produce a CO3 2 minus. So because we know that, the concentration of Pb and the concentration of CO3 are the same number. We don't know that number, but let's just call it x for now. So if we let solubility be x, now we've got an equation that says Ks equals x squared. This is really helpful because now we only have one unknown variable and we can solve this. So you put in the Ks that you've been given, 7.4 times 10 to the negative 14 equals x squared, and consequently x equals 2.5 times 10 to the negative 7 moles per litre. Alright, now let's try another example question. This time I'll give you a wee bit of time to get ahead of me, and then I'll work through it straight afterwards. So I'll give you a minute to start thinking about this question.
Shoo. That's not a minute, that's 5 fucking seconds. Solution is fully... Okay, let's take a screenshot of this and let's do this question. Pause. Gotta save my time here, man. My solution is fully saturated. Fully saturated, what the fuck? Okay. Concentration of Zn2 plus equals 4 times 10 to the power of negative 7 moles. And CO3 2 minus equals 4 times 10 to the power of negative 7 moles. What is the Ks? Okay. Oh, yeah. Ks is equal to the concentration of Cn2 plus times the concentration of CO3 2 minus bracket. What info does this question give you? It's fully saturated. What the fuck does that mean? Yeah, I have no idea what that means. I can't remember what does saturated mean again? I can't remember.
Hey there everyone, and welcome to Chemistry 3.0, remembering that solids and liquids are not included in the solubility product expression.
Yeah.
This will give me a Ks equals Zn2 plus times the concentration of CO3 2 minus.
Right.
Next, I would fill out what information I've been given. I've been given the concentration of Zn2 plus as 4 times 10 to the negative 7 moles per litre, and I've been given the concentration of CO3 2 minus at 4 times 10 to the negative 7 moles per litre.
Okay.
Using the Ks equation I've written in step 1, I can now substitute those two concentrations in and work out the Ks value.
Oh, for fuck's sake.
So that's what I've done there. And now step 3, solve. I've written out the concentration of Zn, written out the concentration of CO3, and I've worked out that the Ks is 1.6
that's the
times
most
10 to
basic
the
thing we've
negative
ever
13.
seen. Come on.
Now those are the main concepts for solubility questions, and being comfortable
the
and
common
able
ion
to
effect.
do those types of questions will ensure that you get an achieved or merit on this section of the course. However, the excellence questions often involve something called the common ion effect. As we know from the Ks equation, a solution can only have a certain concentration of a pair of ions before it becomes saturated. But in all the situations we've been doing, we've been using a solution that has neither of the ions there at all to start with. The common ion effect occurs when one of the pair of ions is already present in the solution. Because there's already one of the ions you're interested in the solution, it means that you're not starting at a concentration of 0. This means less of the thing that you add to the solution can dissolve before Ks is reached and the solution becomes saturated.
Huh?
So I'm going to walk you through an example using AgCl in a solution of water compared to AgCl in an NaCl solution. What you can think about here is you can think of it like a basket of fruit, and this basket of fruit only contains apples. We're not interested in anything that isn't an apple. The red apples in this situation are going to be Ag+, and the green apples are going to be Cl-. Notice that Na+ doesn't have anything to do with this situation. The reason that it has nothing to do with this situation is because you're trying to add AgCl. So the only ions that might become saturated are Ag+ and Cl- ions. Na+ ions from the NaCl solution will be completely irrelevant to this question. And that's an important concept when thinking about the common ion effect. Moving back to the baskets metaphor. On the left-hand side, we have a solution of water. Notice how the water has no Ag and no Cls to start with. I mean, it's completely empty, and the concentration of Ag+ is 0, and the concentration of Cl- is 0. This means we can add more AgCls to the basket before the basket becomes full, or the solution becomes saturated. So here I'm adding 1 AgCl to the solution and it's dissolving. I'm adding 2 AgCls, and that's dissolving in the solution too.
Let's go.
I've added a third AgCl, and it's dissolving in the solution as well.
Yo.
The solution is full up of AgCls now, so no more can dissolve. All the rest of the AgCls that you add will stay as solids. However, in the case with NaCl, you've already got a lot of chloride present, or a lot of green apples present in your basket. This means there's not much space and the basket fills much faster. In this situation, only 1 AgCl can dissolve before the basket is full, or the solution is saturated. Now looking at these two baskets, you can see clearly which one dissolved the most AgCl. The one with water in it dissolved 3 AgCls.
Dude, move on.
Whereas the
fuck.
one that already had chloride in it only dissolved 1 AgCl. And this can be
AgCl.
summarized as follows. The common ion effect is when the ionic solid dissolving and the solution share a common ion, and the solubility will be reduced. Another
Think of why you think the solubility will be reduced. Okay. Yeah, I'm just thinking that there's more ions in solution, and so the left-hand side of the equation is favoured. Right, that's what I'm thinking.
Another important point about the common ion effect is you measure solubility by the not shared ion.
Yeah.
And you might be wondering what I mean by that. Well, if you calculated the solubility of AgCl by counting the concentration of Cls, you're going to say lots of AgCl dissolved. But that's not true. Lots of NaCl dissolved, and a tiny bit of AgCl dissolved. So to calculate the concentration of AgCl that's dissolved, you have to measure the ion that's not shared, the Ag. And the concentration of the Ag will tell you the solubility of AgCl. So hopefully I didn't lose you there. But let's work through another example to solidify our knowledge. So what we're doing is we're calculating the solubility of barium sulfate in water versus the solubility of barium sulfate in a 0.1 mole per litre sodium sulfate solution. The Ks of BaSO4 is 1 times 10 to the negative 10. So let's start by doing it in water.
Okay, let's do it in water, pussy. Ks equals x squared, x equals 1 times 10 to the power of negative 10. It better not be blood. Zero point zero 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 one. 0.0001. This one, the solubility is 0.1x. 1 times 10 to the power of negative 10 is equal to, divide both sides by 0.1. It's way smaller. The solubility is way smaller. Instead of 0.0001,
Same three steps apply that always do. You write out the equation, and you work out that's a 1-to-1 ratio. You write out the Ks equation, remembering not to include solids in it, and then, because it's a 1-to-1 ratio of Ba2 plus to SO42 minus, we can call Ba2 plus x, SO42 minus x, and have an equation Ks equals x squared. We then put in the information we're given, Ks equals 1 times 10 to the negative 10, and we solve. So hopefully that was nice and easy. So now we're going to do the same thing, except instead of being in water, the BaSO4 is in a 0.1 mole per litre sodium sulfate solution. Now the first thing you need to do in questions where the common ion effect is asked about is to identify which is the common ion. So to do that, you write out the equations.
SO4, no fucking
I suggest
shit.
when you do this, you keep the equations separate so you don't get confused about where you're putting your numbers. So on the right, we have our equation BaSO4 going to Ba2 plus and SO4 2 minus. And then we've written out the Ks equation and worked out there's a 1-to-1 ratio of ions. This is exactly the same first step we did for BaSO4 in water. The extra step is we're going to write out the equation for sodium sulfate. So sodium sulfate as a solid turns into 2 Na plus and SO4 2 minus, a ratio of 2-to-1 ions. The reason we've written it out is so we can identify what the common ion is. And so as we can see quite clearly now, the common ion is SO4 2 minus. The next step is putting in the information we know. So what info does the question give us? One piece of info the question gives us, the concentration of Na2SO4 is 0.1 moles per litre. We also know Na2SO4 is in a non-reversible reaction to 2 Na plus and 1 SO4 2 minus. Using these two pieces of information, we can work out the concentration of SO4 that's present before we add any barium sulfate. In non-reversible reactions, all the reactant is used up. All the Na2SO4 has split into Na plus and SO4 2 minus. Every Na2SO4 that splits gives off 2 Nas and 1 SO4 minus. So from this we can work out that for each litre of Na2SO4 that splits, it will create 0.2 moles of Na plus and 0.1 moles of SO4 2 minus. So now we know how much SO4 2 minus we've started with before we start calculating the solubility. And so the third step is to solve the question now. We know that Ks equals Ba2 plus times the concentration of SO4. X, if you remember back to the very first slide, adding a very good answer, it will give it significant. The amount that could dissolve in water was 1 times 10 to the negative 5 correctly. You need to remember never to include solids and never to include water.
Pause time. Let's go. Ferment technique is pussy. Ionic product. The amount of ions present in solution. Easy. Next question. Easy. Okay, let's do a couple of Anki notes. Then the timer will end, and then I'll fuck around for 5 minutes. Then come back to see you guys and study. Put a nasty pimple on my neck. Dude, I've got 21 questions to you. What the fuck? What's the trend for first ionization energy? I'm surprised my sister. She's gonna yell at me soon. She's gonna yell at me soon. What's the trend for first ionization energy? The amount, so first ionization energy increases across a period, but it decreases down a group. Let's go. What is reflux used for? It's used to speed up reactions without losing one of the compounds to a state change. Let's go. Define standard enthalpy change of formation. The amount of energy required to create 1 mole of a substance from a constituent element. Good. Amide base hydrolysis produces a carboxyl ion plus an amine. Let's go. What is filtration used for? Gee man, what is filtration used for? Used to separate compounds based on their solubility. The more dense compound can be filtered off, or the less dense compound can be scooped off. Moving solids from liquids, fuck's sakes. What is distillation used for? To separate compounds based on their boiling point. Good. Perchloric acid molecular formula, HClO4. Let's go. Good. Dipeptide. A dipeptide are 2 amino acids joined. Hess's law. The enthalpy change of a reaction is independent of the route taken. I'm nailing these, Jesus Christ. Acyl chloride plus an alcohol. Easy. The sum of standard enthalpies of formation of products minus the sum of standard enthalpies of formation of reactants equals the standard enthalpy change. What? Let's go easy. Primary amide plus what makes a carboxylic acid? That's HCl, baby. Easy. The standard enthalpy change of formation of the products minus the sum standard enthalpy change of formation of the reactants equals the standard enthalpy change. Come on, man. Easy. In lab techniques, what is the use for reagent sodium carbonate, Na2CO3, or sodium hydrogen carbonate, Na2HCO3, to neutralize or get rid of acids? Fuck, why did that scare me? Easy. What is the separating funnel used for? To separate compounds based on their solubility. The more dense compound can be filtered off, and the less dense compound can be scooped out. Good. Probe, that's 4. That's 3. Fuck's sakes, I'm saying easy still. Enthalpy change, standard enthalpy change. That's good. A ketone does. Easy. What is standard enthalpy of combustion? The amount of enthalpy, the enthalpy change when 1 mole of a substance is combusted completely using oxygen. It's burnt completely using oxygen, or the heat energy released. That's easy. Aldehyde plus what? KMNO4. Easy. What is saponification of a triglyceride? That's a alkaline hydrolysis of a triglyceride, where the triglyceride is split into its corresponding triol and a sodium carbonate ion. easy. What is filtration used for? To separate solids from liquids. Dope. Okay. I'll be back. Go get some brain food. I was just thinking about it, dude, when my sister comes here, I become a worse person. Like, my vibe that I'm letting off is a lot worse, it's a lot more fucking depressing, get into more arguments, but, that just shows a fault in me. I'm switching up when different people are around, so maybe I'm not as mature as I thought I was. You know? Maybe I'm not as mature as I once thought that I was. That's my problem, man. That's on me. That's my beat. Right, let's have a look at my trade me and my ping. Let's manage this. How does ping work? Wait. Did Train Me take their fee and then Ping also took a fee? I think it did. I think they take a 50th, 0.43 times by 50. 21. 1.09 times 50. 44. No, not exactly. 55.67 divided by 1.09 is equal to... Oh, did I fuck up? 1.09 divided by 55.67. It's not a 50th. It's a bit less. Times that number by 22, and you'll find 0.43. Huh. She, homie, she. Blinded by the light. Was blinded by the light. Wrapped up like a goose. By the way, with my Trade Me listings, a couple of things sold. I think 4 games sold. 2 of them didn't sell last time, so that's pretty cool to see. And they were the exact same price. One of them was only $5, the other one was $8. But things that did sell. Oh, I think 3. Yeah, no, you're right. 3 things did. Call of Duty. That one sold for $8. That's pretty cool. So 3 things that didn't sell last time sold this time. Dope. Things that did sell. My own PS4 Black Ops 3. My own Minecraft PS4 game. And then Champions Return to Arms. That sold for $52 plus shipping. Ooh. And I bought that game for less than $1. I bought 9 games for $7. That one sold for $52. Wii Cricket. That was in the same lot where I bought for $7. That sold for $22. But a ton of these Xbox games that I bought for $4 each. That was the first time I went garage selling and I didn't actually negotiate. Sold for $4 each. Just didn't get any interest at all. Like fuck all views, no bidders and watches. Guess Xbox 360 games don't do that well. What will end up happening is none of them will probably sell. None of them will sell this time. And then next time I'll have to lower the price, and then the time after that, what I'll probably do is just bundle them together and in the description say, if you want just one separate game and you don't want to buy them all, contact me. Things that didn't sell as well. Nerf Zombie Strike. That has a bidder and watcher now and 4 views. It's just a Nerf gun for $15. Deal or No Deal. That didn't sell. It's now got 1 bidder and watcher and 1 view for some reason. That happened last time too, and then the bidder and watcher unwatched. I bought this for the Deal or No Deal game for $2, set price of $15. Nerf gun for $3, set price of $15. Nerf gun was probably a bad buy because it's difficult to ship. Hopefully the person just picks it up. The Deal or No Deal was a better game, but still, $15, like that's not a lot. That was from a thrift store though. From a thrift store. And Winnie the Pooh. Where's Winnie the Pooh? Where are you, Winnie the Pooh? What the fuck? I can't actually see him. Oh. They had 2 bidders and watches but didn't sell. Reserve price of $20. I bought that from a thrift store for $4. Coco Disney Pixar Purple. Festival Skull. It's a Disney toy. Reserve price of $10. 1 bidder and watch it but it didn't sell. Bought it for 50 cents at a garage sale. This PS2 game isn't selling. Kingdom Hearts. Blinded by the light. Okay. Let's go back to work. You're blinded by the light. Wrapped up like a goose. Oh wait, I think I'm doing NCA pass exams, aren't I? Let's go. Blinded by the light. Wrapped up like a goose. How many pages I've done? So many pages. You're blinded. They're gonna contact me about that bike. Oh. "2015, 2016, 2017. Let's go. Because I was blinded by the light." I might just do all of this question 1, eh? Fuck it. Question 1. A. Dissolving in water. KS. Oh no, it's not the KS equation. They just want it dissolving in water. CH3 NH3Cl. Cl. Solid. Equilibrium. Arrows. Backwards and forwards to. And fuck it, I'll chuck H2O up there. It's gonna be CH3NH. CH3NH3 plus Cl. CH3NH3 plus aqueous plus Cl minus aqueous. Easy. Except it wasn't too easy. Write an equation to show the reaction occurring in an aqueous solution of CH3. What? Blinded by the light. Is this even KS? I don't think it is. Fuck me, it wasn't. The fuck, man. It's actually question 2 that I need. Write the equation for the equilibrium. Write the equation for the equilibrium occurring in a saturated solution of CaSO3. Okay. Because I was blinded by the light, so wrapped up like a goose. Mm-hmm. Ks is equal to the concentration of Ca2 plus times by the concentration of CO3 2 minus easy. Aye, Captain. Ks equals fraction of 5.74 times 10 to the power negative 5 times by 5.74 times 10 to the power negative 5. Ks is equal to blinded by the light. Five 5.74 times 10 to the power of negative 5 is equal to, square that bitch is equal to 3.29 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. What's this solubility product measured in? I can't remember. B. Some marine animals use calcium carbonate to form their shells. Increase acidification of the oceans poses a problem for the soul. Marine animals. Right, that's cool. That is really cool. Explain why the solubility of CaCO3 is high in acidic. An increase more CO3 2- reacting with decreasing the concentration of CO3 2-. And the solubility increasing cool. Show by calculation that a precipitate of lead 2 hydroxide PbOH2 will form. This is complex ions. Seconds up. Yeah, it is complex ions. Will form when 25 ml of a sodium hydroxide solution in OH at pH 12.6 is added. Is this still Ks? Or have we got a pH in there? Is added to 25 ml of 0.0042 moles per liter lead nitrate PbNO32 solution. This is what? Okay. Show by calculation that a precipitate of lead hydroxide will form when 25 ml So a precipitate is forming. There's more ions. Will form when 25 ml of a sodium hydroxide solution in air OH at pH 12.6 is added to 25 ml of 0.0042 moles per liter lead nitrate PbNO3 solution. What the fuck? So basically, I'm just proving that PbOH2 is formed when NaOH is reacted with lead nitrate. Whoa, this is crazy. What the fuck is going on? Why have we got at pH 12.6? You're just saying that you completely dissociate? I think it's just saying, I already know it's a strong base. It completely dissociates into Na plus OH minus. NaOH completely dissociates into Na plus OH minus. Hopefully I don't have to do anything with that fucking pH. Right? I mean, I can, but... PbNO3 2 just completely goes into Pb 2 plus 2NO3 minus. And so, yo, I'm blinded, blind. S is equal to the concentration of Pb2 plus times the concentration of OH bracket squared two H squared. Okay. Because I was blinded by the night. Alright, let's do IP because that's what it is. Because I'm proving a precipitable form. IP is equal to that. Concentration of Pb2 plus is equal to so we put 0042 CO concentration times by 0.5. Concentration 2OH is equal to this one is just are you serious, man? So with the pH I had to figure out the concentration. Dud. Negative log of 14 minus 12.6, which is just 1.4. Times 0.25, I think. It's just a log of 1.4. What did I put? Why am I tripping? Is this right? pH equals, oh wait. pH is equal to the negative log of H3O plus. Negative log of, right, 10 to the power of negative pH is equal to, right, that's pH, negative log of, whoa. What the fuck? Alright. 10 to the power of negative pH. Negative log times concentration of H3O plus is equal to pH. 10 to the power of negative pH. Negative 1.4 is equal to times 0.25. So we need two OHs. That's the concentration of OH. Fuck it. (9.95) times 10 to the power of negative 3. IP is equal to 0.0021 (9.95) times 10 to the power of negative 3 squared. IP is equal to square that number times 0.0021 2.08 times 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Power of negative 7. Yeah, you fucked up. I need IP to be tiny. Oh wait, no, did I fuck up? No, you didn't fuck up. IP is bigger than KS. Yeah. Cause I was blinded by the line, wrapped up like a goose. Okay, that was good. That was a good past exam. Loki do. See if I got any of these questions right now. Cause I was blinded by the line, wrapped up like a goose. Question 1A. Is this the right exam? I feel like it's not the right exam because you have some random ass shit there. I'm gonna say no. What exam was that? It's 2015. Bingo. And X-ray serum. Yes. That's wrong. Okay, let's go to question 2 then. CO3, solid. CO2 plus CO3 2 minus. Dope. Case equals CO2 plus. Yep. Dope. 3.29 times 10 to the power negative 9. Dope. The HCO plus from the acidic solution reacts with HCO3 2 minus. This reduces CO2 to minus causing equilibrium shift towards Yep. Dope. Got that right. C. 8.34 times 10 to the power negative 7. She. 2.105 times 1.99 times 10 to the power negative 2. Times by. Oh man, I was so close. Yeah, you didn't need to do 0.25. You didn't need to do 2 OH, just OH. Fuck. Okay. Almost. If you have a look at your answer, 2.08 times 10 to the power of negative 7. Just times by 2 and you'll get. Oh wait. Yeah, I was close though. Almost. Almost though. Blinded by the light. What do I think I'm doing after this? What am I to do today? Still chemistry weaknesses. I could do some amide stuff through YouTube. Yeah, it's probably the player. That's probably the play. Because I was blind in my life. Organic compounds, let's go. 15, fuck. Open a new tab. 15. 16. 17. Awesome. Dipeptides and shit. Yeah, for sure. For sure. Cause I was blinded by the light. Fuck it, I'll watch this video.
Greetings everyone, welcome to...
Okay, yo, blinded by the light. Creepy. Yo, blinded by the light. Or do I have one notification? Oh, he's picking up the game. Okay. Blinded by the light. Okay, items. Okay, let's go to soul. Okay, so all of these games are being shipped. I think these are the big games. Keel. I might actually run out of these soon. All these notes I have just saying, hey, thanks, man. Can you please place positive feedback? I need positive feedback. I don't got much. Please. Literally World at War. These PS3 demo games. Black Ops 3. In the bag that's like slightly smaller. Wake up like a douche. Blinded by the light. Ready to rumble. Cause I've been blinded by the light. game champions return to arms. I put them away. Oh no, I'm almost out of bags. This is what my little note says. A little handwritten note. Cheers for winning my auction. Hit me up if anything's wrong. I'd appreciate a positive feedback. Cheers, Flynn. Hey. And you're blinded by the light. Here are my little notes. Here are all my games I'm selling. This one sold, this one sold, this one sold, this one sold, this one sold for $52. Let's go. You're blinded by the light. Okay. Let's start studying again. Let's go.
Question 3 of the Level 3 2019 Organic Examination for Level 3 Chemistry. Let's get started. So this question, like expected, heavily based on condensation polymerization, because that's what I feel is probably the most difficult part in this particular standard. Well, it may be your weakest part in organic chemistry, but maybe after this video it should be your strongest, because it's quite straightforward.
Yep.
So let's get started. So nylon 66 is used to make airbags, blah blah blah. So this is the diamine, this is the dicarboxylic acid. So we want to draw a section.
Diamine and dicarboxylic acid. Dude, that's a motherfucking diamide, baby. Let's go. So you move the H from there and the OH from there. We got water. We're combining them together. It's a dub. Let's go.
Of the nylon 66 polymer.
You showed 2 repeating units. Okay, so
To show 2 repeating units. Now, this is what I always tell people in my class. I will just go, all right, think of the year 12 monomers and making polymers. Think about like you're the only one type of monomer, and then there are like a million of you lining up in one straight line, and then you decided to hold hands. That's additional polymerization. Condensation polymerization is kind of like you and your best friend, and then there are a million clones of you and your best friend, and then you decide, you open your arms out and you hold hands, and then you alternate. So you and your bestie, and it just goes on and forth. And then you react, you release something, and then during the process you combine together. Okay, so
that's a fucking weird example to use for your class.
If you struggle with these, I tend to recommend people to do it like this at the beginning. Just draw them out first. I don't really care about what's in the middle. It's what's on the end that matters. Okay, so I'm running out of space a little bit, so I'll just be very conscious of my spacing. And then CH2 COOH.
What are you doing?
I'm not going to bother with that side because I can't fit anymore. So you need to realize that this is a condensation reaction, because the OH and the H, they are going to go and make water. So these things are no longer there because they want to make water. And during the process, you and your bestie start to hold hands, and then you join
Why
together.
the fuck do we keep
And that's a
running this?
condensation polymerization. So the easiest way.
Sorry, I feel like I'm fucking 8 years old again, being toxic, just constantly trying to crack little dubs at the teacher. Yo, why me and my piss holding hands, Mr. Teacher? That's gay.
So I'll just do it properly here. So we want 2 repeating units. So it goes like this. You can do, I'll make sure I space my thing better this time. CH26. A lot of condensation polymerization is to do with the copying and pasting. If you want to do the hard way, of course, because I think a lot of you are struggling with this, so I'm just going to do the hard way first, then I'll show you the easier way.
What the fuck are you saying?
So if you don't like, yeah, as you can see, this is time consuming. Oh, why did I decide to do the long way? But it doesn't matter, I'm running out of patience. Let's just do the side here, so you can see this H, this OH, want to make water, and then you join together. This OH, this H, join together, then you make water, and you connect everything together. So the end product is going to look something like this. CH26, so they want 2 repeating units. Oops.
Have you done an
H2,
H2, you fucking
H1.
moron? Don't even have that
Actually,
H2, have that
I
H down at the
prefer-
side, man. There you go,
Just to make it
buddy.
more clear, put the H up top.
Oh, shit.
Actually, let's
Oh, what?
use...
Oh, I didn't know that. It just directly bonds. Right. What was I thinking? I was thinking that it bonded directly to the O. The C makes a lot more sense, though, doesn't it?
a different color pen. Let's go with the light, let's go with the green. Hopefully you can see this color. Oh man, it's an ugly green, but let's live with it. And H. So it's a lot of copy and pasting. Okay, so I just sometimes when I teach, I just tell my guys Control C, Control V, write it down, copy it, paste, and you're done. Okay, now this is where I'll stop. I'll bracket, then I'll do an N. Okay.
But it's two. Okay. 2 repeating units, right? They give you like no space to do that.
Now this is how you can check if you've done this question properly. And you may go, but you shouldn't that be NH2? Like, shouldn't this be NH? Shouldn't that be another H?
Nah, you fucking moron.
Why did you bracket it here? This is why, guys. Let me just show you. You know how I told you before with the CON bond? You always cut here. You look for the CON bond, you cut here. You look for the CON bond, you cut here. And you should be able to see that this thing I just underlined and this thing I just underlined are exactly the same. And then these things that I underline with the blue and these things I underline with the blue are exactly the same thing. So if I put an H, like say if I put an H2 here,
Dude, this podcast is
can you see that they are no longer